Two worlds separated by billions of kilometers. One is wrapped in a thick orange atmosphere, with rivers, rain, and seas made from liquid methane. The other is a frozen dwarf planet drifting in the darkness beyond Neptune. Titan and Pluto should be completely different, but when the James Webb Space Telescope examined their light, it found something disturbing. Both worlds were missing light at exactly the same wavelength. Scientists searched their chemical databases. Nothing matched. And now, somewhere on the surfaces of Titan and Pluto, an unidentified substance may be hiding in plain sight. Titan is Saturn's largest moon. Its surface is concealed beneath a dense, nitrogen-rich atmosphere and a permanent orange haze. Beneath that haze are dunes made from organic material, mountains of ice, and lakes filled not with water, but methane and ethane. Not with water, but methane and ethane, wrapped through vocal advanced northwest one-step advance towards Socrates. Pluto is dramatically different. It is smaller, colder, and surrounded by an atmosphere so thin that it can partially freeze onto the ground. Its surface contains nitrogen, methane, and carbon monoxide ice. Titan is active, hazy, and wrapped in weather. Pluto is distant, exposed, and frozen, but both possess environments dominated by nitrogen and methane chemistry. That shared chemistry may be the first clue. James Webb did not photograph the mystery substance directly. Instead, it detected its fingerprint. When light interacts with a material, certain wavelengths are absorbed. That leaves dark gaps inside the spectrum, almost like a barcode created by the molecules themselves. Astronomers can compare those gaps with laboratory measurements and identify substances located millions or even billions of kilometers away. But while examining Titan, researchers discovered an absorption feature centered at 5.113 micrometers. The feature appeared in observations from two separate Webb instruments, NIR-SPEC and MIRI. That made a simple instrument malfunction far less likely. Then the scientists checked Webb's observations of Pluto. The signal was there as well, centered on the same wavelength. Whatever was absorbing this light appeared to exist on both worlds. The researchers compared the feature against published laboratory spectra for simple ices and organic molecules expected on Titan. None reproduced the observation accurately. On Titan, the absorption was approximately 6 to 7% deep. On Pluto, it was around 4 to 5% deep, but approximately 3 times broader. That difference may mean the same compound exists in different physical conditions on each world, or the signal could come from a related family of molecules rather than one identical substance. Several candidates remain possible. They include molecules from the alene family and, under certain mixed conditions, benzene or ketene. Acetylene is considered a less likely possibility for Titan, but none currently provide a complete match, so scientists are facing an unusual problem. The telescope can see the fingerprint, but chemistry has not yet provided its owner. The leading explanation begins high above the surface. Ultraviolet radiation and energetic particles can tear apart nitrogen and methane molecules in an atmosphere. Their fragments then collide, rearrange, and create increasingly complex organic material. Some of that material can descend toward the ground, almost like a slow, continuous fall of organic snow. Researchers believe the mystery compound may be created through this atmospheric chemistry before settling on the surfaces of Titan and Pluto. On Titan, the signal became weaker toward the visible edge of the moon. That behavior is consistent with a feature coming from the surface rather than high in the atmosphere. Pluto provides another clue. Its atmosphere is probably too thin to produce an absorption feature of this depth, making the surface the more plausible source. The researchers also checked Ganymede, a moon without Titan and Pluto's nitrogen-methane atmospheric system. The signal was not detected there. An unknown organic compound on two distant worlds sounds provocative, but there is currently no evidence that this feature is a biosignature. That distinction matters. Organic chemistry does not automatically mean biology. Carbon-based molecules can form without living organisms. However, Titan is valuable precisely because it allows scientists to investigate prebiotic chemistry, the chemical processes that may occur before life emerges. This unidentified material could therefore reveal another step in the transformation from simple atmospheric gases into complex organic compounds. Not proof of life, but perhaps part of the chemical road that can eventually make life possible. Scientists are analyzing additional Webb observations to map the feature across Titan. If the signal is strongest near dunes, craters, or particular terrain, researchers may discover how the material forms and where it accumulates. Laboratories on Earth will also attempt to recreate Titan and Pluto's temperatures, ice mixtures, and radiation environments. But the most dramatic investigation may eventually happen on Titan itself. NASA's Dragonfly mission is currently targeting launch no earlier than July 2028 and arrival in late 2034. Dragonfly will fly between different locations and analyze material directly from Titan's surface. Its mass spectrometer may identify some of the compounds being considered as the source of the mystery signal. However, Dragonfly does not carry the infrared instrument needed to observe the exact 5.11 micrometer feature directly. It may discover the chemical ingredients, but scientists will still need to connect them with Webb's missing light. Perhaps the signal belongs to a molecule we already know, trapped in a form never reproduced inside an Earth laboratory. Perhaps it represents an entire family of compounds whose fingerprints remain incomplete. Or perhaps these distant worlds contain chemistry that our databases have never encountered. For now, Titan and Pluto appear to be carrying the same hidden message. James Webb can see where the light disappears, but we still cannot read what the darkness is saying. What do you think is hiding on these two worlds? Tell us below, and subscribe to Cosmic Civilizations as we investigate the next mystery beyond Earth.